All right, so taking a look at number 22, we are still graphing inequalities, except now you'll notice that we are given two inequalities to graph. All right, so we're going to follow all of the same rules as we did in 20 and 21, except now we're going to add one additional rule, and that has to do with the word that separates our two inequalities. We're either going to see an and, which we do in this case, or we're going to see an or. All right, and we'll talk about what that word means towards the end when we actually start shading. But for now, let's just go ahead and deal with putting each of these inequalities on our grid, graphing each of these inequalities. And we're going to do that just like we did in the previous two videos. So nothing has changed there. So you'll recall in the previous two videos, we didn't let this inequality sign scare us. We pretended it was just an equal sign for the purposes of graphing our line. So we're going to take this inequality, 2x minus y is greater than 4, and let's go ahead and rewrite it, except this time let's switch out that inequality for an equal sign. All right, and you'll remember that we can solve or graph rather this equation now exactly like we would any other time. We can either choose x and y intercepts, or we can come up with other points, or we can put this equation into y equals mx plus b. Whatever you want to do for graphing is perfectly fine. I'm going to go ahead and use y equals mx plus b. And so we'll go ahead and subtract 2x from both sides, and that leaves us with negative y equals negative 2x plus 4. And then if we divide by negative 1 on both sides, we'll end up with y equals 2x minus 4. All right, so this is now our equation just rewritten in slope-intercept form. So we know how to graph this line, don't we? But before we go ahead and graph it, let's go back to the original inequality and see what either we were dealing with a greater than or less than, or a greater than or equal to, or less than or equal to, because you'll recall when it's less than or equal to, or greater than or equal to, we have to use a solid line. So a solid line when we graph that inequality, or if it's simply greater than or less than without that little or equals to, we're using a dotted line. And so that's the case here, right? So we have a 2x minus y is simply greater than 4, and so we know we're using a dotted line. All right, so let's go ahead and go plot this line. So we are going to go to negative 4 on our y-intercept. And then from that first point, our y-intercept, we're going to use our slope, which in this case is 2, right? And we're going to go up 2 units, so up 2 units and over 1 unit. Up 2 units, over 1 unit, up 2, over 1. And again, you can do this an infinite number of times, as many times as you want, but we really only need 2 points in order to graph a line. All right, so now that we have several points here on this line, let's go ahead and graph. And we said we're going to use a dotted line to graph this particular inequality. All right, perfect. Or close to it, right? Okay, so now let's go ahead and determine which side of this line we're going to be shading on, either above or below. And just like we've been doing, we're going to go ahead and choose a test point. And the easiest test point, you'll recall, is 0, 0, the origin. And you can always use 0, 0, this origin, so long as your line does not go through that point. All right, so you can really choose any point you want on your graph so long as that point does not lie on your line. And in this case, we can clearly see that 0, 0 is not on our line, so it's definitely probably the easiest point to use. So this is our x, this is our y, and we're going to take this test point and plug it back into the original inequality, and we want to test to see whether or not when we plug this point in, we get a true statement. So we have 2 times plugging in that 0 minus plugging in the 0 is greater than 4. Well, let's evaluate. 2 times 0, well, that's just 0, minus 0 is greater than 4. And so let's go ahead and simplify for the last time. 0 minus 0, well, that gives us 0 is greater than 4. Is this a true statement? No, 0 is not greater than 4, and so this is a false statement. And so in this case, since the test point we chose was above the line, that means any point above this line will also give us a false statement. And we know that we only shade on the side of the line where the points make our inequality true. So if the points above the line make our inequality false, we know then that the points below our inequality must be where we're shading. These are where our answers, our points, are going to be true. All right, so we've graphed this first inequality, so we're good there. Now let's go ahead and graph the second inequality. All right, and this is simply x is less than or equal to 4. All right, well again, we're not going to let this inequality fool us or scare us. We're going to treat it just like we would an equal sign. So we have x equals 4. Well, how would we graph that on an ordinary basis, right? Well, we would simply go to 4 on the x-intercept, and we're going to draw a vertical line, aren't we? But first, let's find out what kind of line are we going to draw, dotted or solid? Well, because this is a less than or equal to, we're going to have a solid line. So we're just going to draw a line that goes, oops, a little nicer than that, hopefully. It goes up and down, something like that. All right, and now we want to decide where are we going to be graphing, or shading rather. And when you have lines that are either horizontal or vertical, the shading becomes a little easier because all you're doing is you're kind of taking your inequality, this x is less than or equal to 4, and you're asking yourself, where are the values of x that are less than 4? Are they to the left of this line or are they to the right of the line? All right, and you can clearly see that to the left of the line, the x values are getting smaller, right? They're going 3, 2, 1, 0, so on. But to the right of the line, they're getting bigger, 5, 6, 7, 8. And so if we are deciding whether or not to shade on the left side of this line or the right side of the line, we want to go to the left because this inequality is asking us for all x values that are less than or equal to 4. So in this case, we're going to be shading to the left of our line. All right, and now that we have graphed both of our inequalities and we've shaded now for both of our inequalities, we want to go back to the original, and I'll go ahead and erase some of this, and take a look at this word in between the two inequalities. When the word that separates our two inequalities is and, A-N-D, that means you want to go back to your graph and you want to look to see where your graph is double shaded. And we can see here that this little triangle is double shaded, right? It has both red and blue shading. Above here, we just have red shading to the right of the red line, and below the blue here for a little section, it's just blue, right? So we want to go back to the graph and look for the double shaded portion, and we want to go ahead and make sure that we really graph that part of or rather shade this part of our graph and make it dark and make it evident that this is the part of the graph that we want to highlight as being our answers. Because when your word that separates the inequality is and, the answers are just the double shaded portion. It means only the points that are found in this double shaded region here you can plug in and get true statements for both of these inequalities. If you were to choose a point from just the red shaded section, it would only work for the x is less than or equal to 4. If you were to choose a point from just the blue shaded region, that point would only work for the inequality 2x minus y is greater than 4. But if you choose a point from this green shaded region here, you could plug that point in and it would satisfy, it would make both of these inequalities true. And so when the word is and, you are looking for the double shaded region. And again, make sure that you go back to the graph and really emphasize this part of the graph as being your answer. So go back and really shade that part so that your professor knows that I'm trying to indicate that this part here is my answer. All right, if the word that separates your two inequalities is or, any part of the graph that's been shaded is your answer. All right, so you don't have to go back to your graph and double shade anything or make any shading darker, right? Anytime that you have an or, you've already have your answer, because this is saying that any part of the graph that's shaded is satisfactory. That's all they're looking for. So you don't have to do any additional shading. But when your answer, or when your inequality rather, has that and in between, you have to go back to your graph and just double check to make sure that the part of the graph that's double shaded really does look like it's darker, and you can clearly see that that's the region of the graph that contains your answer.